Everyone, in this particular video we are going to solve the problem from Irodov, the problem number 1.10, and that is related to kinematics. So let us first read out the problem and then we'll solve the problem step by step. So there are two bodies that were thrown simultaneously from the same point, one in the straight up and the other at an angle theta is equal to 60 degree to the horizontal, and the initial velocity of each body is equal to 25 meter per second, and it is asking to neglect the air drag and find the distance between the bodies t is equal to 1.7 seconds later. Okay, so let us first consider that we are having the origin, okay, and this is x direction, this is y direction, so this is horizontal direction and this one is the vertical direction. Okay, and there are two bodies, one is thrown in the upward direction. So let us say from this origin one body is thrown in the upward direction, let us say body A, and another body is thrown at an angle of 60 degree to the horizontal, 60 degree to the horizontal, let us say this is body B. Body A has the velocity of 25 meter per second and body B is also having the velocity of 25 meter per second. Okay, now there can be the different methodology to solve this particular problem. So in the first methodology, what we can do, we can find the position of body A and B, and then we can find the distance between those two positions. Okay, and in the second methodology we can use the concept of relative velocity. So let us say if we consider the body A at rest, then body B will have the relative velocity with respect to body A, and then we'll find the location of body B in the reference frame of body A, and then we'll find the distance between the origin and body B after 1.70 seconds, and this distance will nothing but the distance between body A and body B in actual frame of reference, in ground frame of reference. I hope this is clear. So let us first write the velocity of A, that is given as 25 j cap because it is in the vertical direction, and for velocity of B we can take the component. So this is the velocity of B and this particular angle is 60 degree, it is given as 25 meter per second. So this particular component we can write 25 cos 60 degree, which is 25 by 2, and this particular component is 25 sin 60 degree, so this is 25 root 3 by 2. So velocity of B we can write 25 by 2 I cap plus 25 root 3 by 2 j cap. And now we want to find the relative velocity of A with respect to A, that we can write velocity of B minus velocity of A. What is velocity of B? That is 25 by 2 I cap plus 25 root 3 by 2 j cap minus 25 j cap. So this is 12.5 I cap, and this we can find out 25 root 3 by 2 minus 25. This will get minus 3.35 j cap. So this is the velocity of B with respect to A. So this is the velocity we have got. Now we know that, let us say this is the velocity of B with respect to A, then this is 12.5. Let us say we can call it as ux, and this particular component is minus 3.35. Let us call it as uy. Okay, now we can find the distance traveled in the x direction. So distance traveled in the x direction, we can write Sx is equal to ux into time, because let us neglect acceleration in both x and y direction. So we can find out this as 12.5 into 1.7. So we'll get 12.5 into 1.7. So we'll get 21.25. And if we find the sy, that is the distance traveled in the vertical direction, so you can write uy into t. What is uy? Minus 3.35 into what is time? 1.7 seconds. So we can write minus 3.35 into 1.7 second. So this is equal to 5.7 meter. Okay, now we know that the B with respect to A has started from the point B, point origin, and it has reached to this particular point, which has the distance of, in the x direction we have the distance of 21.25, and in the vertical direction we are having the distance of minus 5.7 meter. So basically denoting this as a minus is just meaning that it is not in this direction, it is in the opposite direction. Okay, and this particular coordinate we can write 21.25 comma minus 5.7, and then this particular distance we can find out as distance is equal to 21.25 whole square plus minus 5.7 whole square under root. And then if we calculate this one, we can get 21.25 whole square plus 5.7 whole square under root will get 22 meter. So this is the distance between the origin and the point B in the relative frame of reference, and this is the same distance we'll get in the distance between the body A and body B in the ground frame of reference. So I think the entire concept is clear. Thank you.